roots and radicals, I guess. They call it roots and radicals. So we're going to do 7172 tonight. All right, the usual kind of format. And then it looks like 7374 on Monday. So we'll kind of see how things go. Okay, so it looks like we're rolling here. Let's talk about square roots. They just call it roots and radicals. I'm going to call it square roots and radicals. Okay, so first of all, you're going to need some sort of a calculator to do some square roots. Also to do some cube roots and fourth roots, because the author kind of does some of those. Okay, so make sure you kind of have that available. But the other thing that we're going to need is just, and I think I did this once for you already, is just a list of these, what we call perfect squares. It would be handy to have them.
You're going to put it up on the board?
Yeah, I should, shouldn't I? I thought it was showing. Sorry.
You were writing, or you were...
Yeah, I was writing, and I had the laptop thing here going, and then still had a blank screen. So how about that? Here, let's go back to this. That's what I'm doing. Thanks. So we have 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Okay, these are our squares. Okay, and they will come in handy for you as we progress on tonight and Monday of next week, and also, of course, when you take your test. So it would be nice to have, you'll need those things. I don't know if you can use them on your test, but you'll be able to at least use them on your assignments and so forth. All right? And if you can kind of generate them, that would be great. So it's just 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, so forth. All right? So let's take a look at some square roots, everything we'd ever want to know about them. A square root. So basically there's a definition that says the square root of A, well, if we take the square root of A squared, we get what we say is A, because like here the square root of 4 is 2, because 2 times 2 equals 4. Okay, I mean, that's the idea. All right, so this is a symbol for a square root. Okay, check mark with a tail kind of thing. All right, so that's our square root symbol. And there are actually 2 types of square roots. Let's just talk about what they're going to ask you to do is just do some evaluating, okay, which means you can use a calculator if you want to, but these are pretty straightforward. So like the square root of 25, I could just come down to my 25 and see that it's 5, or I would just know it's 5, because most of you probably do. All right, or you can use your calculator, use the square root of 25 and hit it and see what it says. All right, so you can do that. Same thing's going to happen if we have the square root of, say, something different. If we have a 17, then that one's not on the list, so I pretty much have to use my calculator. Let's see if I got here. Calculator, Let's see, I gotta double check and see the format. That's 17, and I push the square root button. Good calculators are done the way you say it. So if you said the square root of 17, you would type square root 17. This one's not that great of a calculator, so I had to go 17 square root. So you just got to kind of figure out which one yours is. All right. So this we would say is, notice that that thing goes for forever. All right. There's no pattern to it. 4.12. All right. This thing continues to go as a decimal because it's an irrational number, and you learn that either in 60 or a previous math course. So most of your the numbers, they're decimals that go on forever, are irrationals, and most of your roots are when they're not nice round numbers. Okay. So there's basically two types of square roots. There's a principal square root, and the principal square root is what we are doing right now. Okay, so when we talk about, say, the square root of 36, well, that's equal to 6. Okay, that's the principal square root, the one that we would most likely think of. However, if we took -6 and we squared it, we would also get 36. So really, the square root of 36 is equal to plus or minus 6. Okay. So most of the time, though, you don't consider the negative part of it. You know, if you were doing something where you had to find a square root and it was in a construction sort of situation, obviously you're not going to worry about the negative part. You're only going to worry about the principal square root. But a square root in mathematics really has two answers, a plus and a minus. Okay, so that's a square root. But most of the time, you're just going to be given the principal square root to me. All right. So again, if we just want to do here, let's say we have the square root of 9. Okay, well, we would say that's 3 if we were just looking at the principal square root. But in reality, it could be plus or minus 3, again, because -3 squared is equal to 9. Okay, so when you're doing these problems here, they're going to assume that you're going to just find the principal square roots. You don't have to worry about the negative part. But you should know it. Yeah, it is there. I'm just looking at some of these other ones here. We can have a square root of a fraction. In this case, you would go square root of 1 over the square root of 49. 1 over 7. Again, that 49 is up here. There's our 49. Okay. So if you have a situation like that, you're just going to square root both of them. Same thing if we had 1 over 4, square root of 1, square root of 4. And you can do that part in your head, you know. I mean, you can kind of divvy it up and figure it out. Now here's one. Actually, I was going to show you this. I'm going to switch for a second. I don't know if this is helpful or not, but we'll find out. Okay, so I'm going to go like this. X equals square root A plus B. And do all that. And then down here I'm going to go X equals square root A plus square root B. Okay. So, let me change this guy here to 0, and we'll go up to, to 15. What the heck? Can go by ones. And then same thing here. 0 to 15, go by 1. Alright, so the idea is, let me get rid of this. So the square root of a plus b, some people think is the same as the square root of a plus b, where the square root sign is different, right? So this is the square root of a plus b together, where this is separated, okay? But if we play this, and right away you can see that the red one and the orange line don't match up, all right? So if I play both of these guys, and we get different numbers, they don't really ever match up, except there's one point where they come together there. Otherwise, they're not. Okay, so it doesn't really matter. This is all some bunch of numbers. You can see that it's checking a bunch from 0 to 15, and these two things are definitely not equal, except that this one case right back there probably where they were both 0. Okay, so even though it looks like these things are the same, they really aren't. They're only going to be the same when they have zeros there. Okay, so I thought that was kind of cool. I was going to show you that. Okay. So what does that mean for us? That means if we take the square root of 4 plus 9 on the inside, that would be equal to the square root of 4 plus 9, 13. Don't know what that is. I'd have to use a calculator for that. But that's different than taking the square root of 4 plus the square root of 9. Because in this case, we would take the square root of 4, which is 2, plus the square root of 9, which is 3, and we get 5. Okay? And the square root of 13 is definitely not 5. You've probably tried it, and it's going to be something close to 3 point, not sure. 3.6, okay, but definitely not 5, okay. So those two things are different, okay, even though some folks kind of think, man, wouldn't they be the same? No, they're not. They're different deals. Let's see. We could do this. We could take our calculator, and let's see what happens if I go. Let's see, I want to put a negative number in there. So let's see, 12, negative, nope, that's a point. Clear it. 12, oh, there's a negative button. Square root. Invalid input. Okay? Invalid input. What the heck does that mean? Well, it means this. We cannot take the square root of a negative number because remember that the square root means I'd be multiplying this thing and they're the same, okay? So there's no way I can have the same number here and multiply them and get a negative because it's impossible. The only way we can get a negative is if we have one positive, one negative. Can't do it. So this one here we say is just undefined, or you could say no solution or no value. All right, but usually we just say it's undefined. Okay, so we cannot take the square root of a negative number, even if it's a nice 16, it's still going to be undefined. Okay, can't do that. Now you can do this though. That's okay, because now the square root's on the outside, right? So then we can do that. If it's on the inside, but if it's on the outside, we're okay. So here we would just take the square root of 16, which is 4. Somebody says 4. Make it negative, and there's my answer. Okay, so I take the square root of 16 first, figure out what that is, got it, and now I just make that answer negative. That's okay. But we can't take the square root of a negative number. All right. Let's try 0. So if I go here, let me get this, move this kind of out of the way. 0, I'll clear it, I guess. 0, square root. Yep, that's okay. I can take that, which makes sense because obviously 0 times 0 equals 0. So that makes sense. Okay. So that's a bunch of stuff on square roots. Okay. Things nothing really too earth-shattering there as far as that goes. Then they talk about cube roots and fourth roots. Okay. With cube roots, again, it's kind of good to know some of these. All right. Fourth roots, I don't know if he was. It gets a little bit much after that. Okay, so we got 1 cubed, 2 cubed, 3 cubed, 4 cubed. Okay, a cube root's going to look like this. They're just going to put a little 3 up there. Okay, if you don't know calculator-wise, it's going to change. It's going to vary with your calculators. So on this one, I don't even know if it will do it. I'm looking. Oh, yep. Right here. So if I go 125, and then I got to push this. No, that wasn't it. I thought maybe that might be it. Let me try this. Ah, there we go. I got it. So we're going to go 125 up, and then this. Yeah, bugger. I'll make a liar out of me. 125 up, that, root, okay. Let's just get the dang syntax on this. 125 up, root. Root 3, 5. There we go. So for yours, okay, you want to look for probably a key that looks like this, okay, or a button that looks like this, something like that. All right, those will work, and then you just kind of got to find the right sequence. So mine, I had to push a button to get it there, and then 125, push the button, and then I had to push a 3 so it would tell it was a cube root. All right. So if you're not sure how the sequence goes, ask me and we can probably figure it out. So that would be your button for that. I think that's the only button I can think of that it's going to be something along those lines. Okay. Oh, you can't do it in Desmos, by the way. Let me show you that. Let me pop back in here. Show you where it is in Desmos. Get rid of this. Get rid of this. In Desmos, you can do it by entering the functions on the side here. And then I think it's under miscellaneous. And there it is. So it's like half a square root button to check with an N. Okay, so it's under functions, miscellaneous, right there. And I could just put 3 and then put 125. Boom. Okay, so it's pretty slick. Do it in Desmos if you want to. All right, you just go to functions and then find it right there. Okay. If we wanted to do a fourth root, let's try a fourth root. So then I would go same button. All right, put a 4 there. Yeah, I just made up a number. All right, that's going to be the fourth root. Okay. So that might be your best bet than playing around with your calculator. If you can't figure it out, just use Desmos. Pretty simple. On a cube root, you can do a negative here because a negative 2 times a negative 2 times a negative 2 is going to give you that answer. Cube root's going to be a little different. So in this case, I'll wait for it to pop up here. -2 times -2 times -2 does give us a -8. So then that's okay. All right. Okay, so square root, can't do it. Cube root, you can do it. Obviously, what's going to happen in the fourth root then? Yes or no? No, can't do it in the fourth root. Okay, so you see it in the pattern there. I think that's everything there is in that first section. The first part is all evaluating, and then the other parts are using your calculator, and then there's a cube root and a fourth root section. So, and then we have a couple problems with square roots. They do have some applications on. They give you one here. I think I might have signed it. I'm not sure. Talks about breaking distance. That's a square root. Pendulum swings. There's a little square root there, and some other stuff with volume actually has some square roots in it. So they got some applications. Any questions on square roots? It is Valentine's Day. Some of you might want to go home, I guess, early, maybe. I don't know.
That would be nice.
That'd be nice?
Yeah.
We'll see what we can do. My wife's away someplace, so she's at a book thing or something, so I don't see her. All right. 7.2 then. Multiplying and dividing radicals. Okay. But really the most important part of this section is on the simplifying them. Okay. And that's where that chart's going to come in handy, is when we have to simplify them. So radicals and roots are kind of like fractions in a way. All right, so I can explain that a little bit more today and then some next week. But first thing we want to do is learn how to simplify them, okay? So if I have the square root of 40, okay, I can take a calculator, figure out what the square root of 40 is, get an answer, round it, tenths, hundredths, whatever, and that would be fine. But in some cases, we need to have what we call an exact answer. So there's a difference between evaluate, okay, / calculate, and simplify. All right. So this is where it gets a little tricky when we're doing things on tests and quizzes. What's the difference? Well, again, if I'm going to evaluate or calculate, I'm going to use a calculator and figure out what that is. All right, so let's see, that's about 6 points, pretty close, probably 6.4. Okay, but if I'm going to simplify it, then I'm going to take that chart that I had, and the idea is to find the largest perfect square that goes into 40 evenly. All right, so just to review, we had 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, so forth. So, what is the largest of these numbers that goes into 40 evenly? 4 does. And how many times does 4 go in there? 10 times. All right. So this is kind of how I do it. Now, you might do it. So you guys might do it a different way. Maybe you learned it a different way, and you show it. So you're showing it a little differently. That's up to you. All right. Now I can take the square root of 4 because I know what that is. Square root of 4 is going to be how much? 2. The 2 is going to come on the outside, but 10 I can't do anything with that, so it stays on the inside. And that's what is in simplified form. Okay? So that looks a lot different than 6.4. All right? And in a practical sense, 6.4 is going to be more useful in a real world situation. I mean, you're not going to go cut a board 2 square roots of 10. All right? Or you're not going to measure something that's 2 square roots of 10. Doesn't make any sense. 6.4 does. But there are some situations where we want to have an exact answer. Okay. So let's try another one. So let's go with, let's try 72. All right. So we want to find, and again, we're trying to find the largest number that goes in there. Okay. That's called that greatest common factor. We want to find the largest number that goes in here. If we don't, then we might miss it to where this number could actually be reduced again. Okay? So we're trying to find the largest, and I'll show you a situation where maybe we don't. So here we go. What's the largest number that goes into 72? 36. Which one? 36. So 36 goes in there how many times? 2. Okay, so now what's the square root of 36? So the 6 comes on the outside, 2 stays on the inside. Okay? So let's say you didn't know 36. You just said, I'm going to go with 9 and 8. All right? Because I actually heard somebody say, 9 goes in there. Yeah, 9 does. So the square root of 9 gives us how much? 3. So that would come on the outside, and 8 would stay on the inside. The problem is that 8 can also be broken down, right? What goes into 8? 4 and 2, see? So that's the issue. So then we'd have to break it down again, and we probably don't want to do that. All right, so this 2 would come out here and become 6 square roots of 2. Okay, so you really want to try to find that largest one. It's going to save you a lot, because most of the time you're probably going to get the largest one and then stop. You're not even going to check. All right, so that's why you want to try to get the largest. All right, let's try some more here. Let's go with 24. Okay, we're simplifying. What's the largest number that goes into 24? Again, we're looking at those numbers evenly. Four goes in there how many times? 6, yep. Okay, so what's this gonna equal then? Square root of 4 is 2. 2 goes on the outside. 6 stays on the inside. Okay, 2 square roots of 6. All right. Square root of, let's see, 4, yeah, well, we go 48. 48. So now we need the largest perfect square. It goes into 48. So we're going to check that list. What's the largest perfect square? It goes into 48. 16, good job. How many times does it go in there? How many? Close. 3. Okay? So what's the answer going to be? 4 square roots of 3. Yep. Okay? 4 square roots of 3. Now your calculator's not going to do it. Desmos isn't going to do it for you. All right? They just give you the approximate answers. We're getting exact answers. So there's no way to go around it but do it this way. Now, it is possible to have one, and it's already simplified. You can't simplify it anymore. All right? So if we had the square root of, say, 21, are there any perfect squares that go into 21? No. None. So it's done. We can't do anything more with that. Okay? So it's already simplified. So it's a lot like, some fractions can't be reduced, right? Because nothing goes into them. So it's pretty similar that way. Let's do this. Let's multiply first. So how do we multiply? So let's say we have the square root of 6 times the square root of 8. Okay. Well, this is pretty straightforward. It's just going to be the square root of 6 times 8. Okay. All right. 6 times 8. So we're just going to multiply the numbers that are inside the square roots. Okay. It doesn't get rid of the square root. It's not 6 times 8, and that's the square root's gone. Okay. It's going to be the square root of 48. But all of our answers have to be simplified, so we'd have to simplify that. And I think we did 48 already. Yeah, there it is. So when you're doing these problems, okay, just like with fractions, they got to be reduced. You got to simplify them. So make sure that you simplify them. So let's try some more here. We'll go square root of 5 and the square root of 12 gives us the square root of 60. Okay. But is that simplified? Can we break that down anymore? Anything go into 60? 6 and 10 do. Are 6 and 10 perfect squares though? No, see, that's the thing. Again, you can only use those numbers, right?
4 and 15.
4 and 15. Yep. And I wish I had a way to that, I could have you just put the number in it, would spit them out, but there's no way. You just got to work through it. Okay. So what's this one going to turn out to be then? 2 square roots of 15. Okay. 2 square roots of 15.
So if none of these numbers go into it, then it's done?
It's done. Right. So if we didn't have anything that goes into 60, we'd have been done with it before it did. Okay. All right, I'm going to step it up just a little bit. Let's say we have a 3 out in front this time. Okay, and we have a 2 here, and let's go with 20 there. Okay. No, I don't want to do 20 because that's going to work out good. Let's do okay. All right. So in this situation, we're still going to multiply these two, but we're also going to multiply these two. Okay. So it's the number out in front and the number inside. So it's going to be 6 on the outside. And then we need 5 times 14. What does 5 times 14 give us? 70. So again, now I'm going to check. Okay, does any of those perfect squares go into 70? I'd probably maybe check 4. Because, I don't know, I think 4 might. Does 4 go into 70? No. Okay. Let me see. Let me zip up here and look at these. let's see. I'm probably not going to check 9 because I got a 0 at the end. If 4 doesn't go in there, I doubt 16 does. I know 25 doesn't. I mean, you're going to get to a certain point to where these numbers are going to be too large anyway. So they're just not going to go in there. So that one's done. Nothing's going to go into 70. So then we leave it. But the idea is that we multiply the numbers on the outside and the numbers on the inside. Okay? So it's pretty similar to a fraction. When you multiply it, you multiply the numbers on the top and you multiply the numbers on the bottom. Okay? It's very, very similar to fractions.
So why is it that you wouldn't use a 1?
Why is it you wouldn't use what?
A 1.
Because you're just going to get 1 and 70.
Okay.
And the square root of 1 is 1, so you just right back to where you started.
Okay.
Yeah.
So it's going to be repetitive.
Yeah. Good question, though. I'm looking at some of these here. Oops. They don't have a whole lot with the numbers out in front of them. But they should. Okay, let's try this. Square root of 3, and now we're going to put a variable in there. Okay. They look like let me write it like they do. Times square root of 6x squared. Let's try this. Okay. So this is going to be a little trickier. We're still going to multiply the numbers. That's going to be square root of 18. X to what power would we have? 3. Okay. So let's talk about this. Okay, so we're still going to handle this the same way. We want to find out what goes into 18. Okay. X squared cubed, that's a little different. So let's treat that just separately for right now. So let's think of that like this, okay? Which we can think of like this, okay? So we can take the square root of anything that's squared because basically square root and a square undo themselves. Okay, so like 2 squared, the square root of 2 squared is just 2. Okay, so they undo themselves. All right, so the square root of x squared is just going to be x, which means we still have this x left over. So it drops down there. So the square root of x squared, okay, square root of x squared is there. Square root of x squared equals x, but this remains. And that's kind of how that works. So then to do this, what I would do is first break the 18 down. What is there a number that goes in 18? 9 does. How many times? 2. So let's put this over here. So what's this going to look like then? We're going to get what on the outside, number-wise?
3.
We're going to get 3 on the outside. What are we going to get on the inside? 2. Now, it's an x cubed, so we just said, hey, we're going to get an x there, and we're going to get an x there. Right, so it's kind of weird, but that's how it works. Now, there's another way of thinking about this. And if this helps you, then good. This is a 2. We just never write it. Okay? Because it's a square root. So it's always said to be 2 there. This 2 divides into this 3. Alright? It goes into this 3 how many times? Once. Goes in there once with how many, what would the leftover be, or the remainder? 1. Okay? So it goes in there once. That pulls out one of the x's and leaves us with 1 inside. Okay, so that's another way of looking at it. Alright, so you can do it however you want to think about it, but that's kind of how that's the whole idea. It's like, how many pairs of these do I have? Well, I only have a pair here. I don't have another pair here, so this one comes out and leaves me with one. So I'm dividing this. 3 divided by 2 gives me 1. 2 goes in there once. That's that, with 1 left over. Okay. So let's try another one. Let's go with, here's one. Let's see, let's go 12x and 6x cubed this time. Okay, let's try this one out. So we're going to multiply the numbers first. 6 times 12, what does that give us? 72. Okay, x to what power? 4. All right, 72 I think we've done already. What's our number that goes into 72 that we can use?
36 and 2.
36 and 2. Okay. So just number-wise, what's that going to look like? What's going to be on the outside? 6 is going to be on the outside. What's going to be on the inside? 2. Okay, now let's work with this 4. Okay? So this is a 2. 2 goes into 4 how many times? Any leftovers? No. So that means I'm going to get an x squared on the outside and nothing with x's on the inside. Okay? Alright? So that's, again, that's one way of looking at it. I don't know if this, if it helps you, if I say, okay, x to the 4th, well, that's equal to x squared and x squared. Okay? So there's 2 pairs. I mean, oops, come on. X, I don't know why it's not drawing all of a sudden here. X, 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 and X. Right? There's a pair and there's a pair. But that's how it works. Okay? It's kind of hard to wrap yourself around what's going on there with that. My pen quit working. Alright, so let's try one more here. Make sure we can. We'll give you some to practice too, I guess. Then we got to do division.
So if it's even, it's always going to end up being the variable squared on the outside. If you end up doing even power.
Well, let's look at let's test that. So what if we had the square root of x to the 6th? Okay, that's even, right? All right. Okay, I got a 2 out here. That's my square root. Okay, so 2 goes into 6. 3. So I get x to the 3rd with nothing left over. Okay, so it's not always going to be an x squared out front, but you're always going to divide by 2 because it's a square root.
So if you end up with an even number, you probably won't have an x left over. Is that odd? You would have an x left over
when we're doing square roots. Okay, because you're dividing by 2. Does that make sense? Yeah. Right. Okay. Let's see. Okay, let's try. Let's just do one more of these guys here. This all of a sudden gets thick now. 5x3 times 8x4. Okay. Let's try this one out. Square root of, what are we going to get on the inside? 40 on the inside. 40x to the 7th. Okay. Okay, let's do the number first, right? What goes into that number? 4 does. How many times? So just number-wise, what are we going to have on the outside? What are we having on the outside? 2. Good. 2 square roots of what's on the inside, just numbers. 10. Now, let's deal with the 7, right? Little 2 on the outside here. It's not there, but it's there. So what's that going to look like? On the outside, we're going to have 2x to the what? 3. 2 goes in this 7 3 times. How about on the inside? X. Okay. All right, so that's how those work. All right. We could have a situation where we have this, where we have a cube root of 32. Okay? And this is all simplifying, right? All simplifying. No calculator whatsoever evaluating. It's all simplifying. So now we have a cube root. So our square root aren't going to do us any good anymore because it's a cube root. Okay, so then I need to go to my little table I made up here on cube roots, wherever the heck that was, and check those out. I thought I made one. Dang it. Oh, maybe I didn't.
You did, it was just up further, I think.
It was up there even further? Oh, there it is. Thank you. So, 1, 8, 27, 64. All right, and I didn't go any further. But I think they have some in here on one of the pages. So, any of those numbers going to go into 32 for us? 8 does. All right. So this is going to be 8 times what number goes into gives us 32? 8 and 4. Okay. Now it's a cube root. Okay. So we can take the cube root of 8. What is that equal to? 2 is going to be on the outside. Cube root, this 4 comes down here. Okay, can't take cube root of 4 because it is a cube root, not a square root. Alright? So that's how those work. Same idea, just a different root. Alright, same idea. Good news is I don't think I gave you too many of those. Alright. So that simplifying multiplication, how are we doing there? Good with that? A little bit. Okay. Some of this square root radical stuff's a little different to wrap ourselves around. Let's do some divisions and I'll get you a little break here. So, division. Really not that big of an issue. It could look like this. And we've already kind of talked about this. Okay, in this case, we just think of it this way. So that'd be 7 over 5. Okay, we're just going to take the square root of the top number, square root of the bottom number. All right, that's what that's going to look like. You could find them looking like this. Oops. Square root of 28 over the square root of 75. In that case, we would just take the 28, break it down, the 75, break it. Do they have, hang on, do they have any like that? Yeah, they do, okay. Okay. So then that's going to be, let's break the 28 down. What goes in the 28 that we can use? That's a perfect square. 4. Okay, so what's that going to equal? 2 square roots of 7. Okay. 75, what's that break down to? 25 and 3, so what's that going to break down to? 5 and 3. Okay. Now you're really not supposed to have a square root in the bottom of a fraction. Okay, that violates laws of mathematics. But they are not. I don't think you're going to get something like that. And if you do, you're just going to have to leave them because you don't learn how to fix that till 7.4. Okay. But for right now, you can just leave them. But I'm just telling you ahead of time. You know, that would be a no thing if, ordinarily. Let's see. You could have some like this. Square root of, how about we go 48 over the square root of 6. Now, if you have a situation like this, okay, you can automatically convert it to this. Now, why would we do that? Because what?
You have to put the square root of 8.
Yeah, because what happens with the 48 and the 6? They reduce, right? Okay, so if you notice when you're doing these that these two numbers, hey, I can reduce that. If I just think of it without the square roots, I can reduce that. Then I would recommend that would be the way to go. You don't have to do it that way, but it's a good idea. But this isn't done. What does this turn out to be? 2 square roots of 2. Okay? All right? So if you can reduce them right away, it might not be a bad idea to do it that way. They will have some variables on these, but I don't know if I gave you too many of that. Okay, so I don't think you have too many of those to deal with. But that's pretty much how you divide. There's not a whole lot. It's not like it's some crazy thing until we Monday when we get into rationalizing. But otherwise, that's pretty much how it works. Okay, you can either treat it like this one and just do that in your head, 7 over 25. You can see we could have written this one as a, but it wouldn't have gained us anything because these don't reduce. So it doesn't make a difference. 4875, break it down. 4816, or 48.6, I can reduce that one, so I'll just treat it like this and go from there. Any questions on radicals? Awesome. Okay, so I'll put some more up there just for you to practice on. Then yeah, I'll visit with some people about their quizzes. So go out and get yourself a little break here, stretch your legs, do whatever. We'll do some practice problems, try to get you out so that you can spend Valentine's Day with whoever you want to spend Valentine's Day with, I guess.